Welcome to The Explainer. So, we're going to talk about something huge today, a brand new AI project that's trying to solve maybe the biggest, most annoying problem in AI right now. You know what I'm talking about. Why do these incredibly smart systems just make stuff up?
All right, so here's the plan. First, we're going to look at why AI seems to have hit this weird plateau. Then we'll dive into this new blueprint, this new idea, and see how it actually performed in a real-world test, the Sapiens test. After that, we'll check out the results, which were, well, interesting, super accurate, but with a catch. And that leads us to a huge breakthrough, a hybrid model, and what all of this means for, the future of AI.
Okay, let's just jump right in. We've all been there, right? You ask an AI something, and it spits back this answer that sounds super confident, totally polished, and is just flat out wrong. They call it hallucination, and it's this massive roadblock. I mean, how can you trust an AI in something important if it just makes things up? So the big question is, why does this even happen? Well, the problem is buried deep down in how these things are built. See, most AIs today are what you could call world simulators. Think of them as incredibly good parrots. They've read the entire internet and gotten really, really good at predicting what word should come next. But they don't actually understand what they're saying. There's no real model of reality under the hood. The whole idea behind Project Sapiens is to build something different, a world model. This is an AI that doesn't just mimic language, it actually builds a logical, structured map of reality inside itself. So if you're going to build a world model, an AI that actually understands things, what's the instruction manual? Well, it all comes down to this one really powerful, almost elegant idea called conciseness. Okay, so conciseness sounds a little abstract, but it's actually something we humans do all the time. It's basically the heart of wisdom. Think about it. Take a huge idea like justice or freedom. I mean, you could write libraries full of books on what those mean, right? They're infinitely complex. But our brains can somehow boil all of that complexity down to a single powerful principle that we can act on. The theory here is, what if we could build an AI that does the exact same thing? An AI that can look at a whole mess of information and pull up the simplest, strongest, most useful idea. So an AI built on this idea doesn't just search for an answer. It searches for the best answer. You could even say the wisest one. And it does this by calculating something called a conciseness cost. For any given problem, it's like it's asking itself 3 questions. 1, am I being redundant? Is there a simpler way to say this? 2, am I losing any important information here? And 3, how much effort does it take to get to this answer? The whole goal is to find the answer with the lowest score, the one that's the most elegant and efficient. Okay, so that's the theory. It sounds great on paper, right? But how in the world do you actually build something like that? How do you test it? That's where Project Sapiens comes in. And listen, the team behind this was super clear. This was not about building just another huge language model. This was about creating an AI that actually understands. And to do that, they had to change the whole process. Forget just training an AI on a mountain of data. The plan here was to educate it right from the ground up. And this is where it gets really cool. Look at this process. Instead of just hoovering up the entire internet, good, bad, and ugly, Sapiens uses what they call verifiable ingestion. So when new information comes in, it's like it gets sent to a panel of experts. You've got a logician module that's checking, hey, does this make sense? Does it contradict anything we already know? You've got a philosopher module asking, is this concept sound? Only when a piece of information passes all these checks does it get added to the AI's core knowledge. It's basically a bouncer for bad information, letting it learn from the web without getting poisoned by it. All right, so they built it, the big moment. What happened when they put this new, educated AI head-to-head with a standard one? Well, the results were really fascinating. And this table just lays it out perfectly. They fed both AIs a stream of information, some true, some false, some contradictory. And Sapiens? It was flawless. It created a perfectly clean knowledge base. 0 contradictions, 0 falsehoods, 0 junk. The conciseness score was a perfect 0. Meanwhile, the conventional AI just ate everything. It swallowed the lies and the contradictions right along with the facts, ending up with a messy, unreliable mess of a knowledge base. But there was a catch. This perfect accuracy had a price tag. And our price was speed, because Sapiens was so methodical, carefully checking every single piece of information, it was noticeably slower. You can see it right here. It was the classic engineering trade-off. Do you want it fast, or do you want it right? The Sapiens model was all about getting it right. So you have this classic dilemma, right? Accuracy versus speed.
You could have one or the other. But this very problem is what led the team to their biggest, most important breakthrough.
Instead of picking a side, they asked, why not have both? They created a hybrid AI. What they did was brilliant. They took the fast, powerful engine of a standard AI, a transformer model, and they plugged the Sapiens conciseness engine right into it. It's like they gave the speed demon a conscience, a logical brain to keep it on the right track. And the results were just, wow, transformative. The hybrid model was almost as fast as the regular AI, but it was just as perfectly accurate as the slow and steady Sapiens model. It got all the logic right. But here's the kicker. It did something extra, something completely new that neither of the other two could do by themselves.
And what was that new thing? It handled a metaphor. For the first time, an AI could verifiably understand an abstract idea. I'm talking about connecting two totally different concepts like time and a river and finding the concise logical link between them. This wasn't just matching words anymore. This was a flash of actual, genuine comprehension.
So this is the really critical takeaway. The hybrid system wasn't a compromise where you get a little of each. It was truly the best of both worlds. You got the rock-solid logic and accuracy from Sapiens, plus the speed and, get this, the creative flexibility of the transformer. The combination was way more powerful than either part on its own.
All right, so what does this all mean for the future? Let's talk about where we go from here, because this really could change everything.
The implications here are just massive. We're talking about a potential end to AI hallucinations. That alone opens up a path to AI we can actually trust for serious work in business and science. But it's more than that. When an AI can handle abstract ideas, it stops being just a tool and starts becoming a real partner for things like scientific discovery or complex strategy. And on top of all that, these models are way more efficient, which is a huge deal for the future of AI.
So, that leaves us with this one big final question to chew on. For years, we've been building AIs that are amazing at predicting and mimicking. But what happens when they finally make that jump? What kinds of problems can we finally solve in science, in our daily lives, when we have an AI that doesn't just predict what we're going to say, but actually finally comprehends what we mean?